Hello students, welcome to the course Digital Signal Processing. In this case, we are going to discuss the unit number 2, that is Z transform. The topic for today's discussion, that is properties of the Z transform. Let's discuss the very first property, that is linearity. In this linearity property, when we say that x of n will have the Z transform, that is x of z, so we can easily obtain over here what exactly the linearity means. So linearity means, so when we go for expression, that is a times x1 of n plus b times x2 of n will have the z transform, that is nothing but a into or a times capital X1 of z plus b times capital X2 of z. So here x1 of n will be converted into the x1 of z. Similarly, x2 of n will be converted into x2 of z. So the overall ROC over here will be the simple reflection of the ROCs due to the x1 and x2. That is what mentioned over here. So ROC is equal to the intersection of ROC of x1 and ROC of x2. So the statement provided for the ROC is the combined ROC is overlap or intersection of the individual ROC of x1 of z and x2 of z. Let's see one example over here, that is x1 of x of n is equal to a raised to n un minus a raised to n u of n minus n. So in this case, if someone just replace this capital N with the value 1, so it will be quite delayed in its step sequence by 1. So what is exactly happening over here? A raised to n u of n, if its ROC is greater than, let's say, uh, mod z greater than mod a, then we can say it is concentrating on outer side of the circle with radius a. Similarly here, if the ROC for this left sided sequence is mod z less than mod a, so obviously we will have a ring kind of fashion over here. Let's assume that a for this one and a for this second case are different, so ROC will be the ring kind of fashion. This is all about the linearity property. Let's see the proof for the linearity property. So for the proof of the linearity property, we will just go on discussing first of all the Z transform definition. So this is where the definition of the Z transform is figured out. So x of z, that is equal to summation n is equal to minus infinity to plus infinity x of n z raised to minus n. Here x of n is equal to a1 times x1 of n plus a2 times x2 of n. So if we put this value of, let's say, the x of n in the equation of z transform, so this is how the equation will become for the entire case. So it will become like this. Writing two terms separately, we will get x of z is equal to summation a1 times x1 of n z raised to minus n after splitting it. So for the second term it will be like this, plus summation n is equal to minus infinity to plus infinity a2 times x2 of n z raised to minus n. So for this to be more clear, we just take the a1 as a constant quantity, so it can be taken outside the summation. So that is where it is just provided at this term that a1 is taken outside the summation. So a1 is taken outside the summation. Similarly, in the second part also we can take the a2 outside the summation. So if a1 and a2 are taken outside the summations, what is the resultant value which we expect other than a1? So this is what the summation x1 of n z raised to minus n. So this is nothing but the x1 of z. So this entire quantity can be simply written as a capital X1 of z. Similarly, for the second case also, this a2 times x2 of z, because this entire term except we can say A2. Let me just point out it. So except A2, this entire term, that is summation, will be replaced over here as a x2 of z. So hence we can easily prove here, considering the left hand side, that x of n, if it is taken as a a1 x1 of n plus a2 x2 of n, then it can be with the z transform a1 times x1 of z plus a2 times x2 of z. So ROC, as we discussed, it is again the intersection due to the ROCs of x1 and x2. So it can be figured out like the combined ROC is overlap or intersection of the individual ROCs of x1 of z and x2 of z. So in this way we can easily prove the linearity property. Similarly, we can go for the further properties also that we are going to discuss, like the property which is mentioned as a, let's say, the time shifting property, then even the conjugation property, even the scaling property. So in the next lecture we are going to discuss further properties. Thank you everyone. Thank you very much.